Previously, we saw the definition of a derivative at a point, right? And so now we can just say, well, instead of, looking at a specific point, we can let that point be variable, right? And that variable can be represented by, say, x. If we do that, then we get the definition for the derivative of a function entirely, right? Over its entire domain. And so if we do that, we get just that f prime of x is equal to the limit as h approaches 0 of f of x minus f of x plus h minus f of x all over h. You could also look at the average rate of change version too, the f of x. So you could do something like limit as x2 approaches x1 of f of x2 minus f of x1, but then we can't really do this because, again, x1, say, is a fixed point, right? And so we're looking at any point. So that's why we don't really want to do the average rate of change, or that version of the average rate of change for the definition of the derivative of a entire function. Okay, so now we have an example. Let's do it. So it says find f of x on the domain of f if, okay, there we go. And so maybe it's just a good thing to note that here, if we're looking at the domain of f, right, we just can't have -1. So we can say that the domain of f is all real numbers except -1. Okay, just making that note. Okay, because otherwise, we could say let's try and find the derivative at -1, and well, we can't because it doesn't exist. Okay, I digress. Let's go ahead and do this derivative. So f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x all over h, right? Okay, so then this is limit as h approaches 0. And then in the numerator, right, f of x plus h, this would be 4x plus 4h divided by x plus h plus 1 minus 4x, so f of x all over x plus 1 all over h. Okay? Now, mathematically, let's do a bunch of steps all at once. Okay, so to get a common denominator, right, I would need to take the 4x plus 4h, multiply it by x plus 1, right? And I would have a common denominator that is x plus h plus 1 times x plus 1, okay? And then subtract, and 4x would need to be multiplied by, 4x would need to be multiplied by x plus h plus 1. And then that h, yes, it's in the numerator of the denominator, but again, if I divide by if I change the division by a fraction to multiplication by a reciprocal, that h is actually still in the overall denominator, okay? Verify it on your own, okay? And then a whole bunch of work later, okay? Again, verify on your own. It should reduce, if you did it correctly, to 4 divided by x plus 1 times the quantity x plus h plus 1. Okay, so this is after, factoring out an h and dividing it out. And then we send h to 0, and we end up getting 4 over the quantity x plus 1 squared. Okay, and so this would be the derivative of a function, of the given function, for any value x within the domain of f. All right, and then before we move on, I just want to make you aware of some different notations you might see for the derivative. So when we do like f tick of x, right, that tick, we actually would say that that's a prime. So we would say this little tick is a prime. So we can talk about the derivative in that way. You might also encounter df dx. This is actually really useful later on in the course and in calculus too when you're studying differential equations. So df dx is just what we call Leibniz notation. And then you might also see f dot with the dot over it, then that's still a derivative, and that's more common in physics. Okay, and then later on in Calc 3, you are going to see derivatives expressed differently because we're in a multivariable setting. So we have multiple inputs, x, y, z, perhaps, and so the curly d's, right, they're still derivatives. It's just meaning partial derivatives. And you'll learn more about that later on. Okay. And then if we can also continually differentiate. So differentiate is the verb of a derivative. So differentiate f prime to get f, we would call this double prime. We can differentiate f double prime to get f triple prime. And then really after that, we don't really do it to a higher order generally, but we would say it's like fn of x would be the nth derivative of the function if it exists. So just want you to be aware of different notations and the language around that. So make sure to make some notes on that. Again, in the process of finding the derivative, we call that differentiating, not derivative. I don't even know how you say that. Derivativing. Yeah, that's weird. I can't even say that. So differentiate to find the derivative. And so the derivative is a noun. All right. So that aside, next we're going to look at some properties of the derivative.